Hi, this is John at Dambest Racing Carburetors and Fuel Systems. I want to do another video, and I always am amused by these videos and let people know that it's truly not easy to get these things done. But I would really want to show the features that can be custom ordered in our new float balls, because over time people will ask the question if I can develop a video and give some understanding and then add to it later, as I've been doing to the construction of the float balls. Gives people a better understanding and you get ahead of the curve on ordering. New float balls have so many new available machining options and ordering options, it would be impossible to list them all. The new interior channel that we machine into it is an open cavity, so it allows the fuel to come down around the float better than any we've used. And we don't use a bolt-in axis pin locator. We've machined it into the housing so that that can be moved as well. I want to show, this is one with one assembled in it, and you can see the float moving and then the needle and seat dropping out. Well, what ends up happening as we're trying to get a greater needle and seat drop for the higher capacity engines, if we raise the needle and the float and the needle and seat in order to get more float drop, we end up covering the window on the inside. So we have a 12 or 1300 horsepower single 4-barrel, and we want to make sure it gets enough fuel. This is for the future because guys are in 11 to 1200 range now. This is what we designed this particular float drop for, is to be pretty safe in the 1200 horsepower range. But we can raise this channel in the interior channel. The whole process in here, the upper channel and the lower channel can be raised so the needle and seat has the same length in through the metal, but it will give a greater flow drop and a greater needle and seat exposure. So I'll bring this one back again. So the upper channel, we can change the size of these holes. Oops. I'm trying to do this by myself. These sizes of the holes, or you can actually feed it from both sides if you so choose. There's an advantage because 360-degree feed on the needle and seat, and as soon as we get to a point, we're going to also increase the diameter of the needle and seat. This particular process will allow us to do that. And we can change the size of the holes for the fuel delivery, and we can change this upper channel to make it taller to compensate for when we move the interior channel up. So we move both of those 100 thousandths, that'll give us a greater flow drop and more exposure to the needle and seat. So that can be ordered for specials. We don't want to do that on, for instance, twin 4-barrel, because part of the problem right now is they overfuel the engine through the high G load areas. So we use the flow drop and the needle and seat exposure to actually limit some of the fuel delivery when there's no flow control. I'll just explain that. When you got a float with 1 G force going this way, then when you leave the starting line at 2.5 G's or more, figure this is 1 horizontal G here, at which point the fuel is opens the float and it has no orientation to close. So that's now 1 vertical G with holding the float ball sideways. So there's a lot going on in the float ball situation. As you can see, that we don't use a mounting bracket for the pivot pin. It's located in the and machined into the carburetor itself, so that it, as we've been building these, we're finding the distance to optimize for our usage. But we've also found the process, so if somebody wants to order, for instance, a different leverage angle based on what kind of fuel pumps and fuel pressure they need, they can have a different leverage angle against the needle and seat. Or in cases they get up around 1300 horsepower, they can order a different height for the needle and seat. The final option will be the depth of the float ball, the interior depth. The current depth of the interior of the float ball is right around 400 thousandths. I just quickly stuck this in there. It's 400 inch 400 deep. when you look at the blanks, the machining blanks allow us to add, so on the outside of this, it's 1.540". So if we go as far as the blank will allow, we can actually add another 1/2 inch to the total assembly. So you can order the float bowl incrementally, anywhere from the current one and adding 100,000ths up to a 1/2 inch more deep for the engines that need more volume. Now, why is that significant? Because when the float level, the fuel level is consumed and the float drops, you also lose weight over the jet. So when people are complaining about being able to maintain a particular air-fuel ratio through the level, it also has to do with the fact, in order to refill the float bowl, the flow is dropping and the weight in the float bowl area is reduced, and that's what pushes the fuel through the jet. You've got the draw of the booster and the weight over the fuel. So as you reduce the weight over the fuel, you're getting a less delivery through the jet. There's less push. The needle and seat is not pushing the fuel, it's refilling the cavity. The weight of the fuel in the float bowl is what actually feeds the jet opening. So you've got the booster signal drawing on one side and the weight of the fuel on the other side. So as you reduce weight, you're reducing a little push. So having a deeper, more full float bowl on the high demand engines maintains a more even pressure across the jet. Now, if there's any additional questions, you know, we put the site in a place that we figure is it's a good place for us, you know, in its normal window, but that also can be adjusted if somebody has another spot that they would like to have it. So in developing the system to make them CNC float bowl, we really leave a lot of options for custom orders. So I hope this helps. If there's any further questions, please let me know. Put that there. I like to see the name. Came out really nice. And I hope you have a great day. Thank you.